The topic of the screencast is the builder design pattern and its simple implementation in the GIMP model. So what is the builder design pattern? The builder design pattern is a creational design pattern for multiple object creation. It's often used when complex objects of a particular class with many attributes are to be constructed. The builder pattern can help create objects with complex constructors that require input of many required and optional parameters. In this pattern, the object construction is generally delegated to a configure builder object class. This is a general UML diagram of the builder pattern. The product class defines the type of the complex object that is to be generated by the builder pattern. The builder is an abstract-based class which defines all of the steps that must be taken in order to create the product object. The product builder is a concrete builder. There could be many concrete builders. These classes contain the functionality to create a particular complex product object. The director class controls the algorithm that generates the final product object. This is the system class model of the GIMP program. Here we will apply the builder design pattern to create instances of the martial arts class. The required parameters for creating an instance of the martial arts class include the class type, the class category, the class ID, the chain of data, and the room number. The optional parameters are the owner data and customer data. This is the UML diagram showing my sample implementation of the builder design pattern for the instantiation of the martial arts class objects in the GIMP program. The methods in the map builder class provides the flexibility in creating the martial arts class objects. This is a demo of the martial arts class with the implementation of the builder pattern. Here is a set of attributes for the martial arts class objects. The martial arts constructor uses the map builder as the input parameters to initialize these attributes. For program simplification purpose, here we use the map builder class as an internal embedded class of the martial arts class. For other applications, the builder class can be outside the product class. Here in the map builder class, we have the same type of attributes as the martial arts class. The map builder uses the 5 required inputs to initialize the attributes for the map builder objects. Then, for the optional parameters, we use the set methods to initialize the attributes. Finally, the build method is used to return a new martial arts class instance defined by this builder. Here we use the main method to test creating instances of the martial arts class. First, we create a martial arts class object with all required inputs. Second, we create a martial arts class object with all required inputs and one optional input. Third, we create a martial arts class object with all required inputs and all optional inputs. The output of this testing program shows that all martial arts class objects were created successfully with all the corresponding required inputs and optional inputs. By using this builder pattern in our gym program, it helps to provide flexibility when instantiating the objects of the martial art class. For example, when a martial art class object is first created, the class constructor does not require the owner and customer information. They are optional, which can be added later. The map builder class contains the method to set up the object with the owner and customer parameters only when it's needed. The builder pattern improves our code robustness and less error prone when creating martial arts class objects, since both the class constructor and implicit method calls are available to the coder. Thank you for watching.